Chapter 6, Section 2, Multiplication and Division. So we're going to look at irrational expressions when we multiply and divide. We kind of talked about this multiplication really when we're simplifying expressions. We're really using this product rule for rational or fractions, right? To simplify, but also we can start with multiplications, and we're going to go through this and do that, and then look at division, which is really just converting it to a multiplication, and then we'll look at some of the strategies. This little study skill thing here is a nice thing to look at, and I think if you've been successful in your classes, you've probably been using some of this. Strike when the iron's hot. It's talking about make an effort to do your homework as soon as possible after each class, or and I would say when we're dealing with lectures like this that are recorded, I would plan it that way. Is you're going to spend some time listening to the lecture and then attempt your homework. I'd also say the other way around. I think a lot of times when you attempt problems first and maybe not be successful, which you can do in your homework and redo, is there's those aha moments that happen. You're going like, oh, when you hear the lecture or you read the book after you've attempted some of these problems, you go, oh, you see the part that was missing, and it becomes a better learning experience. But also the other thing too is to make it a routine. Choose your time and place where you can focus. I think this is probably and have minimum on our interruptions. We're probably good at what I see, and I do this myself too. We're probably pretty good at minimizing our interruptions from other people, but we sure have our own that we bring with us. Our phones, even music. I think you probably want to think about maybe some of the music that you listen to while you're working on things that take concentration. Of course, I kind of like classical music a little bit when I was a kid, but and went away from that. And I grew up in the late '60s and '70s, so a lot of rock and roll stuff going on, and I really liked that music. But it really didn't really work that well for me anyhow. Of sitting down and having to concentrate on some more difficult concepts to have to apply or pick up. So, nice little hint about study habits. If you're struggling with that, or you're struggling with getting your homework done and succeeding and getting as much value out of doing your homework, look at maybe changing some things that you might be doing around that. We did have TV back in those days too, and I was never one that could sit and do homework in front of a TV. The TV would usually take too much of my attention. So just a thought. And I think this is all going to be review stuff, and we're going to really talk about strategies on simplifying rational expressions, while you're multiplying and dividing, and hopefully get really proficient at this and can do this without taking much time. Well, here's our rule. If we have two fractions that are multiplied, it's really numerator times numerator, denominator times denominator. Now, in the case when we were talking about simplifying, well, if we have matching factors that are up there, we can rewrite that as different fractions and so on. So when you have this example here of 3/5 times 8/11, that's really 3 times 8 over 5 times 11, so you get 24 over 55, right? And so on. So they just show those examples. So to multiply, that's basically what we're doing. And they're going to show it this way first in a couple ways, but we should look for, let's look at example A here first, right here. We should look for common factors when we're doing this, and it's saying we're forming the product of numerators and products of the denominators. In other words, numerator times numerator, denominator times denominator. And then they prime factor, and I like this a lot better than when we were going through simplifying. if I prime factor everything, I'm not going to miss any common factors. It's kind of like I don't have to worry about making sure that I have the greatest common factor. I just get all prime factors, and if I prime factor, there's only one prime factorization for any expression, one unique prime factorization. So I do that, I'm not going to miss any common factors, and I'll always come out with the most simplified expression. So they show it in this way to write it all out and all those kind of things, and we're going to talk about some shortcuts as we're multiplying and basically go back to what we did here in the last section. So after all this multiplication with all the common factors, they're showing that crossing out thing, which is really what we're saying is when I cross out this 5 and this 5, I'm really making this 5 over 5, which is equal to 1. And when I cross out this a and match it with this a, I'm getting a over a right here. And I match this 2 with this 2, I get this 2 over 2. So they tell us here in the red basically what those crossouts really are meaning, that we're making fractions equal to 1. And I get that times a squared over 2. Same process when we go through more complicated polynomials. So when I have this trinomial times this rational expression here, what I can do is say, well, what do I do now? This isn't a fraction. Well, I can make a fraction out of anything by putting it over 1. And I would start, before I'd ever even do this part, probably before I even do this multiplication or rewrite it as numerator times numerator. And this is more about style, but I think it creates less steps sometimes. So I'm going to try to do that all the time. So when I look at this, they start factoring, and these here, they list all the factors out. They prime factor this really, even though we have a trinomial and a binomial. Each one of these binomials has no other factors other than itself and 1. That means that they're prime, and this is prime here. And strategies again for factorization. I have a trinomial, I look for perfect squared trinomial. In this case it's not, so they use grouping or FOIL, and then they still have this factor. Well, this one is a perfect trinomial square. And remember how you determine that? At first term something squared, last term is something squared, that's 5 squared. The square roots of these each multiplied together and doubled. If that fits this middle term, I have a trinomial square, a perfect one, which factors into 2 binomial squared in this case. And they just write it out, which has some advantages to it to write out that multiplication. In this case, we have a common factor of x minus 5 between the numerator and denominator, so I get a 1, and then I leave it this way. Again, you could multiply this out and get a trinomial over this binomial, but not unless they specifically tell you to do that. I never do that. That's just an added step, basically, and another chance for an error. So C is really just some more things that are some polynomials that are just a little more complicated to factor. And again, in strategies and stuff like that, so I'm going to show this this example. They do all the factoring. They basically match up common factors, make a 1, a fraction equal to 1, and this is what we get left. If you look at this one over here on the left, what I would probably do before I did anything else, I look for what do we do when we're factoring first? I look for common factors. And I look at this 10t squared and 2t. Well, this has, I could say this is 2t times 5, right? Times t. Well, they have a common factor of 2t. I might, right before I start doing anything, I might cross this 2t out and put 5t right here. Now my numerator's all factored as far as it can go, and then I got 1 times this, so I just need to factor this trinomial if I can, and which I can. So, and then I end up with a t plus 2 that is common too. So I end up with 5t over t minus 1. Okay? So, I just did that in my head because I'm thinking about the pieces that we can factor out. We've been doing a lot of factoring, and hopefully you can get to that point. I wouldn't say do it in your head, especially for a test or something, but look for things and patterns that are going to make this more quicker. Sometimes is an issue, but less steps is usually always your best strategy. Now, division, we had a division rule. Remember when you divided fractions, if we had a fraction divided by another fraction, what do? We just convert it into a multiplication by taking the reciprocal of the divisor. So this a over b divided by c over d equals a over b times the reciprocal of c over d, which is d over c. Now, definition of a reciprocal is when I multiply a number times its reciprocal, I get 1. And if I think about c over d times d over c, I'd get 1, right? So by doing this process, now we have a multiplication again, and we just do the same things and the same types of strategies that we talked about just prior to this. So the parts here, if I have division, first thing I always do before I factor, do anything else, or look for common factors, is change to a multiplication. So x divided by x over 5, which really is a division too, right? But we want fractions to be multiplications. And we end up with this multiplication of x over 5 times y over 7, the reciprocal of this one, 7 over y. Now I have just a multiplication. I don't have any common factors between the numerator and denominator. Everything's factored. I multiply, and that's my answer to that division in this case. Again, I can put anything, make a fraction out of anything. So I got x plus 2 divided by this fraction here of x minus 1 over x plus 3. Well, a lot of times if I put that over 1, sometimes that seems to help a lot. It sure tells you where the numerator and denominator are. And then I convert this to a multiplication by taking the reciprocal, which is the thing I can multiply this times this, and I get 1. That's the definition of reciprocal, which is really you exchange or put the numerator and denominator, flip them over, and that's going to be your reciprocal. So that's what they're reminding us here. By multiplying reciprocal of the divisor by writing x plus 2 as x plus 2 over 1 can be helpful too. They're noting here is, like I said, now there's no doubt this is a denominator, so I'm looking for things that may match that factor in the numerator. Did I say denominator? I mean this is a numerator and this is the denominator. Okay? Example 3 here. Divide if possible, simplify. Okay? So we need to convert it to a multiplication. Always, that's a first step. So if you look at this, here's the first step. I'll kind of walk through the factoring again, and it says multiply by the reciprocal, right? So now I have a multiplication. I follow my multiplication rules, and I factor this as a trinomial. I look for perfect square trinomial. This 3 is not something squared, so I use FOIL or grouping, and I can factor this to be x minus 3 times the quantity x plus 1 here. And then I still have this multiplication of this fraction, right? Well, here's a binomial. First, I kind of skip that. You look for common factors. There's no common factors. Well, here's a binomial, and if it's something squared minus something squared, I have difference of squares, which would factor into this x minus 2 times the quantity x plus 2. So here I have everything all prime factored right here at this step. and then I look for common factors, common primes basically I can make fractions equal to 1 out of, and I end up with this new rational expression. Here's another one. Again, make sure you change to multiplication. Now if they're dividing by something like this, I could make this a fraction too, right? I talked about how's the ways you can make anything into a fraction is you put it over 1. So really this, if I wanted to restate this, is a squared plus 3a plus 2 all over a squared plus 4 divided by 5a squared plus 10a all over 1. That makes the reciprocal a little easier to see, and then they change to multiplication this way. Factor it, look for common factors. There's a common factor right here to factor. There's no common factors here. And here I have a binomial. This is something squared, here's something squared, but that is not a difference. I need a difference for it to be difference of squares, so I can't factor that. Be tempting here, probably a lot of errors around this arena right here where you think, hey, I can factor this to be a plus 2 plus something, but there's no way to factor that, so careful. So then they simplify by writing fractions equal to 1. Okay. This one here too, again, is a good example. When I change this to a multiplication, I got x plus 1 over x squared minus 1. Well, to convert this to a multiplication, I'm going to take the reciprocal of that, and this x plus 1 is going to go down to the denominator. Hey, that cross cancels or basically equals a fraction equal to 1. I could simplify this as I'm writing down my conversion to a multiplication. So think about those things that may help you. Don't take shortcuts if you're not sure what you're doing, but those kinds of things can be real helpful. So I'll talk to you later.